Let's start with internal energy. Thermal energy or internal energy. All atoms and molecules are in constant motion. For example, they vibrate, they rotate. Now this happens, all of the molecules, all of this together. Vibration, rotation, and they move from place to place. Now when you take all of that energy and put it together, it's also called internal energy and is represented by the variable U. So the thermal energy or the internal energy. Now the temperature is a measure of the average kinetic energy of these atoms. They're moving and they cause a liquid then to rise in a thermometer. The higher the rise, the higher the temperature, the greater the average kinetic energy of the material. Of the atoms in the material, I mean. Now, which has more thermal energy, the lake or the tea? Well, the lake has all of the molecules are moving with less kinetic energy, but there's so many billions of them, it has much more internal or thermal energy. But if we said which has the higher temperature, it would be the tea, because all of the molecules have a high temperature. Now, heat is very important. What is heat? We cannot say something has heat. Rather, when a hot body and a cold body are placed together, you have a transfer of energy from the hot to the cold. And so here it is, very important that you understand this difference. The energy that passes between two bodies because of a change in temperature between them is called heat. And for the AP course, it's measured in joules. Now, there's also calories in BTU, but we do joules. Now, temperature is measured in kelvins. If you took all of the energy out of something, they say you have absolute zero, which is negative 273 degrees Celsius. And that becomes zero then on the Kelvin scale. Extremely important. Kelvin is C plus 273, or you can rearrange it to find C. Here's another thing we need to look at, thermal expansion. If you heat certain materials, they will expand. And delta L is the change in the length. Now we're dealing with linear measurements, the length of something. Alpha is a constant called the coefficient of linear expansion. You never have to memorize them, even know its name. It will always be given. L naught is the initial length at a particular temperature. And then delta T is, obviously, the change in temperature. It's a very easy concept, and when you read it in the book, you should understand it after this. Now, suppose I have some kind of a metal, say, and this is the metal. It has a temperature T naught initially, an initial length L naught, and we heat it. Well, now it got a new temperature, it has a different length, and it has expanded by delta L. Now, let's see if we can memorize this. Notice delta L is alpha L naught delta T. Well, picture a Dell computer, and that will tell you delta L, all right? Now consider the little Alt key on that computer. Notice the little alpha. Well, that Alt key, when the computer gets hot, begins to expand. So the Dell computer, the Alt key expands. Thermal expansion, delta L, is alpha L naught delta T. Just stop and make those associations. It'll help you memorize it. Now, when I transfer heat from one material to another, you have this rate. It'll move, and there's a rate of heat transfer. Well, what is this rate of heat transfer? Well, you can look at that block, and this is what the heat is moving through. And it depends on the cross-sectional area, A. That makes sense, I think. It should, depend on how long it is, how much distance the heat has to go through, transfer, and also the change in temperature, and a constant K, which is the coefficient of thermal conductivity. It's just a constant that would be given to you. And there's the formula. Look at it, and now let's memorize this formula. This is heat transfer. So imagine this fire burning up a bus transfer, heat transfer. There's the block. On that block is a little girl named KT, and that tells you the K, A, and then, of course, the T. the Y doesn't count. Well, an elbow comes and knocks her off. Oh, she goes flying off because of the elbow. She goes over, falls over, and you have Katie over and then L for the elbow. Now, I know it's stupid, but you know what? You can memorize it by this kind of exaggerated stuff that captures the fleeting thoughts of your brain. Make the association, learn the formula.